Hello students. In this video we are going to discuss about the chemical properties of group 2 elements, which is commonly called as alkaline earth metals. First, let us discuss reactivity towards air and water. Beryllium and magnesium are kinetically inert to oxygen and water because of the formation of an oxide film on their surface. However, the powdered beryllium burns brilliantly on ignition in the air to give beryllium oxide and beryllium nitride. Magnesium is more electropositive and burns with a dazzling brilliance in air to give magnesium oxide. From this, we can conclude that the alkaline earth metals react radially on heating with oxygen to form oxides, which is generally represented as MO. Here the general equation is given, that is twice M plus O2 giving rise to twice MO. Here M is the alkaline earth metals. But calcium, strontium and barium are also readily attacked by the air to form oxide and nitride. So this equation is a general equation for all the alkaline earth metals on reacting with oxygen to form metal oxide. You can write the similar equation for magnesium, that is magnesium Mg plus O2 giving rise to twice MgO. Next is the reactivity towards halogens. All the alkaline earth metals combine with halogen at elevated temperatures, forming their halides. Here the reaction is between the alkaline earth metal with halogen, which is generally represented as X2. So there is a formation of halides, which is called as metal halides. The formula for metal halide is MX2. That is a general formula which is given here. We can write this equation for all these elements in this way. That is the reaction of beryllium with the X2 at high temperature, that is elevated temperature. The product formation is called as beryllium halide. With magnesium it forms MgX2. With calcium it forms CaX2. With strontium it forms SrX2, and with barium it forms BaX2, which is called as barium halide. In general we are naming this as a metal halide. So here if it is the metal is the magnesium, then we can name it as magnesium halide. If the X is taken as any particle halogen, like if we are doing the reaction of magnesium with chlorine, so the product at elevated temperature, the product form is that is MgCl2, that is now called as magnesium chloride. So the general equation is given here, and the formation of product, that is a metal halide formation, is shown in this way. Next is the reactivity towards hydrogen. All the elements except beryllium combine with hydrogen upon heating to form their hydrides. The formula for hydride, that is the general formula, is given as MH2, where M is the alkaline earth metals. So except beryllium, all the other elements of group 2 combines with hydrogen to form metal hydrides. Here formation of compound with hydrogen is called as hydride, and just now we have discussed the reaction with halogen. There the formation of product is halides. That is the difference here. It is hydride. General representation for hydride is MH2. BeH2 however can be prepared by the reaction of BeCl2 with lithium aluminium hydride. So here the other all elements combines with hydrogen directly to form hydride with heating, but BeH2, that is beryllium hydride, we can prepare by another method, that is beryllium chloride reaction with the lithium aluminium hydride. This is also one type of hydride. What is the name for this one? That is lithium aluminium hydride. So the product formed, it is a beryllium hydride, lithium chloride and aluminium chloride. So by this reaction we can prepare beryllium hydride, that is the reaction of beryllium chloride with aluminium, that is with lithium aluminium hydride. Next is the reactivity towards acid. The alkaline earth metal readily react with acids, liberating dihydrogen. So here there is a formation of a hydrogen gas. That is a reaction of this metal with HCl, that is an acid. It results in the formation of chloride here, because here HCl. Look at the equation here. The positive part get combines with the negative, because the metal here, it is always electropositive. So the positive part of this and negative part, that is Cl. Cl is the negative part in HCl. So the combination result in the formation of MCl2. Now why the formula is MCl2? Because this metal, we know that it is having two positive charge, and we know that the chloride, that is all halides, have one negative charge. So when you crisscross it by the method which you have learnt in 9th standard, so the formula will be formed, that is MCl2. So that is what it is written here. The formula is formed here, that is MCl2. If you want, you can write a particle equation here, that is magnesium with HCl giving rise to MgCl2 plus H2. So here there is a liberation of a gas, and that gas is a hydrogen gas which is liberated here. So that is a reaction of alkaline earth metals with the acid. Next is the reducing nature. Like alkali metals, the alkaline earth metals are strong reducing agent. As we have already discussed in the case of alkali metals, which are good reducing agents, similarly the alkaline earth metals are also strong reducing agent. This is indicated by the large negative values of their reduction potentials. That is the E0 values, which we have already discussed. Why it is a strong reducing agent? Because of large negative values of reduction potentials. That depends upon the different enthalpy that we have already discussed in the case of alkali metals. Next is the solution in liquid ammonia. That is, like the alkali metals, the alkaline earth metals dissolve in liquid ammonia to give a deep blue black solution, that is by the formation of ammoniated electrons. This reaction also we have done in the case of alkali metals. Here also there is a formation of ammoniated electron. This is the formula for ammoniated electron, because there is one free electron here which get excited to higher energy state and come back to the ground state with the emission of radiation. That gives a blue black coloration to the solution. When you compare this equation with the equation, that is the reaction of alkali metals with the liquid ammonia, in that you can find the product formed will be quite same one, but the only here it is two positive here. In the case of alkali metals, here there is one positive charge and here there is two positive charge. So that differences are there. So when you learn these two equation, learn it together so that it will be very easy to learn. Both the equations are quite similar, but here there is two positive charge, but in the case of reaction of metal, alkali metals with the ammonia, there is one positive charge. So it is easy to learn this equation, and the stoichiometric coefficient also differ here. So this is what the equation, that is the reaction of alkaline earth metal which is dissolved in the liquid ammonia. It results in the formation of ammoniated electron, and this is giving the coloration. So in this video we have discussed the different chemical reactions of alkaline earth metal. So all of you note down these better from the textbook, because all these images are taken from the textbook itself. So this is all about this video. Have a nice day.